Here's our first specific area in a polar curve problem. We have r is equal to 4 plus 4 cosine theta. That's this cardioid I've drawn here. Again, I will provide the pictures for you. Any pictures you need, I will provide for you. And we want to set up an integral. Just set up, you don't even need to evaluate it for now. Set up an integral that finds the area of the green shaded region. Now, what I'm trying to, I don't know if you can see this very well, it's just the region of the first quadrant, right? It's just the region of the first quadrant. I don't want this little fiddly bit. I just want this larger region here, all right? So, set up an integral that finds that. What we need is the limits of integration. Well, those are the two angles, right? This is alpha, this is beta, the two angles that we start with and finish with as we sweep out that portion of the curve. It should be clear that that portion of the first quadrant starts at alpha equals 0 and extends through beta equal pi over 2. So we know area. Since this is polar coordinates, we need the 1/2. Remember, that 1/2 comes from the formula for the area of a sector. It's just the constant multiplier that needs to be in place in polar coordinates. In Calculus 3, if you get to take Calc 3, you'll see that actually comes from a little bit different. There's a little bit different way to think of that. But for now, it comes from the area of a sector. Integrals go from, in this case, from 0 to pi over 2. I need f of theta, which is the function value. This is either r squared or f of theta squared. It's the same thing, r, f of theta. It's the same expression. 4 plus 4 cosine theta quantity squared d theta. If all you're asked to do is set up an integral, you have set up an integral and you are now finished. Of course, evaluating this integral should not be too much of a challenge. You know, come final exam day, this is a nice little 2-for-1 problem. Number one, do you know how to set the problem up? And then number two, do you remember your techniques of integration, how to multiply this, how to work this out? If you needed to, now again, for now, you don't need to. All you're asked to do here is set up the integral. But if you need to be able to compute that, then you would square this thing out. This is 1/2 integral from 0 to pi over 2. When you square this, that's 16. What was that? Plus 16 is 32 cosine theta. I'm going to run out of space. (16) plus 32 cosine theta plus 16 cosine squared d theta. And this goes from 0 to pi over 2. And you would have to integrate this. That's not very hard. That's theta. Integrate this. That's not very hard. That's 32 cosine theta, sine theta. You have to integrate that. That's cosine squared. You would need to remember how to integrate cosine squared using the half angle identity from our work earlier in the semester. And you can take this 1/2 and make some of those numbers smaller if you like to. If all you're asked to do is set up the integral, you're out. If you're asked to evaluate it, then you would need to set that up and then also evaluate it.